Okay, so you guys had those units circled out. I probably should have recorded me going like through it, but that's okay. I'll do that another day. Now we've already done number 3, but I erased my answers here for us to work through it and remind ourselves what we did here. Okay. One thing I have not covered up on the board is that x equals cosine and y equals sine. That's what we're about to use here. So again, you probably have work done for most of number 3, but we're going to redo it. If it says find the exact value, that's when I know I'm not using a calculator. I'm using my unit circle. And it says sine of pi over 3. Sine is which variable again? X or y? Y. Good. It's on the board if you forgot. And then can you go to pi over 3 and tell me the y value? On your unit circle, no calculators, go to pi over 3 and tell me your y value. What is it? Root 3 over 2. Good. This is why I want you to know the unit circle, is because we're going to be able to look at this and without even having to use it, without using our calculators, we're just going to know this. Okay. Now we skipped this one last time, secant of pi over 4. However, we now have enough information to deal with it. Secant is what? 1 over cosine, which is helpful because cosine is which variable? Is that my x or my y? It's my x. So it's the same thing as doing my x value at pi over 4. What is my x value at pi over 4? Root 2 over 2, right? So we're going to do 1 over root 2 over 2. Now we're probably like, ugh, a fraction inside a fraction. You can handle that. We get rid of it by multiplying by the reciprocal. So I took the numerator and I multiplied by the reciprocal of the denominator. So 1 times 2 over root 2 is just 2 over root 2. But is that rationalized? No, multiply by root 2 on top and bottom. 2 root 2 all over 2. Oof, can I simplify that even more? Take out that 2 that's on the outside, and I'm just left with square root of 2. So we did not do that one before, but we can do that one now that we know what secant is, okay? Let's go to C and D. I believe you should already have those, but I'm going to run through them again now that we have a little bit more experience with this. So we're going to do tangent of pi over 6. Do you remember what tangent is in terms of x and y? Sine over cosine, good. And if we know that sine is my y value and cosine is my x, we're going to look at pi over 6 and we're going to do the y value over the x value. So I'm going to go to my unit circle. My ordered pair at pi over 6 is going to be root 3 over 2, comma 1/2. So I'm going to do my y divided by my x. We're going to do 1/2 divided by root 3 over 2. And just like we did before, we're going to take that 1/2, the numerator, and multiply by the reciprocal of the denominator. My 2's cancel, so I get 1 over root 3. But is that rationalized? So let's multiply by root 3 on top and bottom. And so I end up getting root 3 over 3. And you might have already had that done, but I just wanted to review. Are you guys okay with what we've done so far? What's wrong?
Oh, I'm a little lost.
What part? Are you lost on how I did this?
No, on how you read that.
Oh, that's just something we know. That's just a new rule. And we're going to do more practice with this, so it'll start going in our head. The last one actually has no work. It says cosine of pi over 3. Cosine is which value? X. And what's your x value at pi over 3? 1/2. Good. All right. We did the next part, evaluate the calculator. Go ahead and jump down to number 5. We're basically about to do the same thing, but we're going to do the reverse of it. This time I give you a ratio, or I give you part of a coordinate point, and you have to tell me what angle it happens at. Right now, I only care about Q1, quadrant 1, which makes sense because I didn't put any other angles on the board, did I? So I'm asking sine of theta equals 1/2. So which angle has a sine of 1/2? Sine is which one, x or y? Y. Which angle has a y of 1/2? 30, good, or pi over 6, good. And I want both of those answers, 30 or pi over 6. So we're just doing the reverse of what we just did. Okay. Let's just jump down to B since I can see that already on my screen. Secant equals equals root 2. Secant is the same as 1 over cosine. And is cosine your x or your y? X. Good. So I'm essentially doing 1 over x. What angle, if I did 1 divided by its x, would give me root 2? Which one's the only one that has a root 2 at all? 45. There's no way that I'm going to get a root 2 out of any of the angles that don't have a root 2. Now, let me prove it to you, okay? If we're not sure, we double check. We're going to do 1 divided by root 2 over 2. Wait a second, didn't we just do that? So if you want to see the work, we can come back up here and we can see this work up here. We just did it and we proved that we got root 2. So I'm not going to show that work out again, but you can go back and look. All right, next one is tangent of theta equals pi over 3. Okay, tangent we just reviewed was sine over cosine, which what is that in terms of x and y? Y over x, good. Okay, if I want my tangent to be root 3, could my angle be 0? No. Could it be 30? It could be. Could it be 45? Absolutely not. Could it be 60? Maybe. Could it be 90? No. So our question here is it going to be 30 where it's root 3 over 2 comma 1/2? And again, we have to do our y divided by x. So it would be 1/2 divided by root 3 over 2. Or is it going to be 60 where it's 1/2 comma root 3 over 2? And when I do my x and my y, we get root 3 over 2 divided by 1/2. Which one do you think is going to leave me with a root 3 on top? The second one. Why do you think that, Sophia? Good. When I multiply this out, the root 3 stays on top and the 2's go away. So I have to do this option, which means that it's that 60-degree angle. So 60 degrees or pi over 3. Now, if you weren't sure, we could do the math out for this one too, but sometimes even just setting it up helps you visualize it enough to know whether it's the 60 or the 30 degree. All right, and then last one, cosine of theta equals 1/2. Which angle has a cosine of 1/2? 60 again, pi over 3. Because again, cosine is your x, so it's 60 or pi over 3. Okay, you don't have to feel awesome about this. We're going to do a lot more practice tomorrow and the next day, but are we okay for right now? Okay, you can put your unit circles away, and you definitely need a calculator for the rest of class. Hopefully the rest of what I'm teaching you, we learned in geometry 2 years ago, so hopefully it's a nice little review. Okay. I've got 2 problems that are kind of setting us up, and then we will get into the word problems about it. All right. If I look at a problem like this, you should know, or at least be familiar with this. We are going to use our SOHCAHTOA. So I would probably write SOHCAHTOA somewhere on my paper close to this problem. We cannot do Pythagorean theorem because I only have one angle or one side and I want another side. I can't do special right triangles because it's a 57, not a special right. So I'm going to take my angle and I'm going to label opposite, adjacent, hypotenuse, and I'm going to decide which trig function I want to use. What is my hypotenuse here? 1. Good. What's my opposite here? 32. What's my adjacent? The other side, right? I have an angle, I have my opposite, that's not what I wanted to do, and I have my hypotenuse. Which trig function am I going to use? Sine. I'm going to do so, and so is indicative of sine. I know it's been a while, but we used to do this a lot. When I do this, I'm going to do sine of my angle equals opposite over hypotenuse. So I'm going to write sine of 57 equals my opposite, which is 32, over my hypotenuse, which is y. Does this ring some bells, maybe? It's like kind of tricky to teach you guys something in the same classroom that I taught it to you 2 years ago. Now we want to simplify. I'm going to multiply by y on both sides to get rid of the denominator. So I get y sine of 57 equals 32. That's an annoying step, but I just don't want a fraction here. So now I'm going to divide by sine of 57 on both sides. And I get y equals, and I'm going to go literally plug this into the calculator, 32 divided by sine of 57. Now, before you press any buttons, I don't remember what we were doing last time. Make sure your mode is on degrees. Remember how we were messing around with mode of radians and degrees last class? Make sure you're on your mode, press the mode button, and make sure your degrees is the one highlighted. Okay, then I'm going to press 32 divided by sine of 57. And I get 38.16.
What mode is that here?
Excuse me?
What mode is it?
Degrees. Notice that the angle in my problem was in degrees, so I need my calculator to be in the same space. Is everybody doing okay so far? Can we do another one just like it? Okay, same idea here. My angle is 71. Let's label opposite, adjacent, hypotenuse. I like hypotenuse first. What's my hypotenuse? The blank side, right? It doesn't have anything on it. What's my opposite? What's my adjacent? X. Good. So I've got opposite, adjacent, and my angle. Which trig function am I going to use? Tan. I'm going to use my TOA. Tan of my angle equals opposite over adjacent. Tan of 71 equals opposite, which is 18 over X. We doing okay with this so far? Exact same way of solving, multiply by X on both sides. X times tan of 71 equals 18, and then divide by tan 71. $18 divided by tan of 71, and I get 6.220. We doing okay? Okay, let's keep rolling. We practice that now because I'm going to do some word problems that we are going to draw triangles and do kind of the exact same method. So if you need to, I'd maybe write SOHCAHTOA at the top of this paper somewhere. And we're going to draw a picture, and then we're going to write an equation and solve. All right, so I've got 5 of these. We're going to get through all or as many as I can get through. Okay, a squirrel is sitting at the top of a tree that is 52 feet tall. He is looking at a nut on the ground. So let me draw my picture. I've got my triangle. And remember in trig, so far, we only can use right triangles. We can't do this with acute or obtuse triangles. They must be right. I'm going to put an S at the top of my triangle to tell me that's where the squirrel is. I'm going to put an N on the ground where the nut is going to be. And then I put a tree at the base of the tree, or a T at the base of the tree. So I know what I'm looking at. It tells us that the tree is 52 feet tall. So I'm going to write 52 as my vertical distance. Is everyone okay with how I've labeled my triangle so far? Okay, the next part says his angle of depression is 23 degrees. Do you guys remember talking about angle of depression back in geometry? It's us looking down. So it's like if I had a straight line right here and I was looking down, that is 23 degrees. Yes. Now, if you also remember from geometry, that is the same as the angle of elevation. So 23 degrees can also be in here. The line of sight on the top is parallel to the bottom, and those two angles right here are alternate interior. I don't know if that's too much of a blast from the past, but you guys are like, ooh, those words are deep in my brain. I haven't thought about them for a while. All right, so I've got that. And now my question is, find the distance from the nut to the base of the tree. That is going to be that bottom distance, the base, and I'm going to just write X there. That's why I label N and T and S, so I kind of know what's going on in the picture, and I don't just label any side X. It's from the nut to the bottom of the tree, so it's that bottom side. Everybody good? Okay, let's label our triangle opposite adjacent hypotenuse so that we can figure out which trig function we need. Where's my hypotenuse? The empty side. What's my opposite? 52. What's my adjacent? X. Which trig function am I going to use? Oh, TOA. Tangent. So we're going to do tangent. And remember when I do that, we write tangent of the angle. So tan of 23 equals opposite, which is 52, over adjacent, which is X. That's a lot like how we just solved a couple minutes ago. So I'm going to be quiet. You simplify, solve, and look at the answer on the board momentarily. All right, I got 122.5 feet. Is that what you guys got? All right, next problem. It says a seagull on the top of a lighthouse spots a fish in the water below. Okay, pause, draw my picture. Triangle. Seagull is at the top of a lighthouse and he sees a fish in the water below. It says the seagull is 87 feet above sea level and he is 230 feet from the fish. The seagull is 87 feet from sea level. Where do I put that number at? The vertical distance. So he is 87 feet above sea level and he is 230 feet from the fish. Where does that number go? The hypotenuse. It goes on my slanted distance. That's not a distance we're used to measuring, but that's what it said. It said from the seagull to the fish. We labeled seagull, we labeled fish. That helps me know that that's my 230. Then it says, find the angle of depression from the goal to the fish. Okay. So again, we can think of our angle of depression like we have been thinking of it. And I'm going to use a theta there for my variable. However, just like we did before, it's kind of weird having that angle outside my triangle. So I'm going to put it down here at that angle of elevation. It's still the same thing. So if that's my angle, now we're going to label opposite adjacent hypotenuse. Where's my hypotenuse? Where's my opposite? And where's my adjacent? Good, the blank side. Which trig function am I going to use here? Sine. Good. How do you know? We've got opposite and hypotenuse, and that is so. Good question. Okay, now it's how I set it up. We said we're going to use sine. Sine of what angle? What am I going to write for my angle? X, theta, whatever makes you happy, just a variable. And then it equals my opposite 87 over hypotenuse, which is 230. We're not going to divide. Does anyone remember how we find the angle if we have the ratio? Get your calculator. Is there a button for that? -1. We're going to do the inverse of sine. So we are gonna say theta equals sine to the -1 of 87 over 230. Basically what we did is instead of dividing by sine, we do the inverse of sine on both sides. And the inverse of sine times sine cancels, give me just theta. And I'm left with inverse sine of 87 divided by 230. So go ahead and press second sine and then 87 divided by 230. I tried, especially with your class, to be cognizant of calling these reciprocals and not inverses, because inverse is the -1. So inverse is -1, so that angle is 22.23. Anybody questions yet? Let's do another one. It says, how far is the airplane from the airport if he is currently 5,000 feet above ground and the pilot's angle of depression to the airport is 17 degrees? Okay. This is kind of a confusing one because the airplane is in the air and the airport is down over here on the ground. The point right below the airplane is just like the distance from the airplane just down to the ground. Where do I get to put 5,000 to show that the plane is 5,000 feet above the ground? I saw some of us do our kind of vertical line. 5,000 is that vertical distance. Angle of depression, we've done that a couple times. That's here. And it's also my angle of elevation right here. And it says, how far is the airplane from the airport? Where am I going to put that? X. Okay. Where would you say, Chase? The hypotenuse. It's going to be from the plane to the airport, so it's going to be there. I know it's very tempting to put it on the ground, the distance it is. That's not what we're doing. We're saying, like, how far is the plane actually traveling? Okay. Trig function is what? Sine. Very good. And this one is kind of like the ones we easily plugged in. Sine of 17 equals 5,000 over x. Multiplied by x on both sides. And I get 17,101.52 feet. Okay, I want to do one more problem and then we can do that last one next class. Good. Last one. It says, find the height of a flagpole that makes shadow 13 feet long when the angle of elevation of the sun is 59 degrees. Okay, draw my picture. Oops, that's too bad. I didn't even recognize that. Okay, we're finding the height of the flagpole that makes a shadow 13 feet. Where's the shadow on this triangle? It's on the ground. The shadow's on the ground. That is one that we often forget. I know sometimes I have to remind myself. The sun is up here that makes like the shadow come down. So it's going like this is like the imaginary line. But when we're like looking at our shadow, we look at the ground to see it. We don't know how tall the flagpole is, but we do know the angle of elevation is 59 degrees. I kind of just zoomed through that. Is everybody okay with how I labeled my triangle? Which trig function am I going to use now? Tan, CHOA, opposite, adjacent. And this is actually probably the easiest one to solve. Tangent of 59 equals x over 13. Just multiply by x on both sides. Or by 13 on both sides, excuse me. And then we're just going to physically do 13 times tan of 59 in the calculator. And I get x equals 21.63. Is that what you guys got? Okay, awesome. Okay, we did great even with this short class. Thank you for your attention and focus. I just want to make sure we got through enough word problems. Your homework is 4.2, and that's due next time I see you. Okay. Have a great rest of your day.